happens. Okay, so today we're talking about quadratic equations, and we actually, my class, we looked at this the last couple days, solving quadratic equations. And what I want to emphasize today, not only will we be solving quadratic equations, but how to know which technique to use, because there are several techniques. The three main techniques that we're going to emphasize today are factoring, the square root property, and the quadratic formula. And so when you look at a quadratic equation, first of all, you recognize that you have a quadratic equation because it's a polynomial equation with the highest power on the variable being a 2. So, for example, over here we have 5x squared minus 10x equals 0. So, what I always think about when I first look at an equation is it easy to factor? Because if you can factor, then it's a really quick and simple solution, and you might as well go ahead and do that. Now, if you look at an equation and it's not simple to factor, you want to think about whether you want to use the square root property or the quadratic formula. And so there are two cases where we can very easily use the square root property. We have the case where we have no x term in the equation, like this one here, x squared plus 9 equals 11. Notice there's an x squared and there's some constants, but there's no x term, like 3x or 5x. So in that case, it's very easy to rewrite the equation in the form of x squared equals a number. Like in this case, we could subtract the 9 to the other side, and we would have x squared must be equal to 2. And in that case, we can use the square root property, and I'll show you how we do that in a minute. The other case where you would use the square root property is when you have something of the form a quantity squared, like a binomial squared, equal to a number. And here's an example like that. So if we see 2x plus 1 squared equals 12, there's no need to go ahead and FOIL that out to multiply 2x plus 1 times itself, because we can actually just apply the square root property and be done a lot quicker. And then the third case, when you look at a quadratic equation and you don't see an easy way to factor it, and it has an x term, and it's not factored into a perfect square equals a number, then in those cases, which is all the rest of the cases, you're going to use the quadratic formula. Okay, so in just a minute, I'm going to solve these specific examples using the methods that I've just mentioned. Okay. So let's start with these first three equations which factor easily. So I want to show you what I mean by factor easily. Hold on a sec. This guy isn't wanting to slide downward. Sorry guys, I'm having a technical problem. Hold on just a sec, I'll figure it out. There we go. All right, so let's say that you are asked to solve 5x squared minus 10x equals 0. So when you see that you have an x in both of the terms, in other words, there's no constant term, then you know that you can factor out a greatest common factor. So in this case, I hope you can see that's a 5. Let me rewrite it here. In this case, we have 5x squared and 10x, and so what they have in common is a 5x. So we can very easily factor out 5x, and then we're going to get x minus 2 left behind. All right, so what's the purpose of factoring? By the way, I should have mentioned that it's important that we have 0 on one side, or else factoring really doesn't help. So why? Because now we know that we have two mystery numbers. We have the number 5x and we have the number x minus 2. They're being multiplied together and you get 0. So the only way that that can logically happen is if one of them equals 0. So we can break this apart into two linear equations, either 5x equals 0 or x minus 2 equals 0. If 5x equals 0, that means x has to be 0. And then if x minus 2 equals 0, that means that x must be 2. So we have found two solutions in our solution set, 0 and 2. Those are both numbers that if we plugged them back into the original equation would make a true statement. Okay, now we're going to solve x squared minus 6x plus 8 equals 0. And since this is one of the quadratic equations where the leading coefficient is a 1, we know that we can very quickly factor it by just using the shortened version of the AC method that we've been using in class. So you multiply 1 times 8, and your a times c, 1 times 8 is 8. And we're looking for factors of 8 that add up to the b value, which is negative 6. So if you go through the factors of 8, we need two negative factors to multiply to give us a positive and add up to a negative. So the factors of 8 that we're looking at would be negative 1 and negative 8, but those add up to negative 9. Negative 2 times negative 4 gives us 8, and those add up to negative 6. So this is the pair that we want. And since we had a leading coefficient of 1, we know this is going to factor into x minus 2 times x minus 4 equals 0. So it factors very easily. And again, we had the 0 on the right. That's why this is helpful, because now we know that either x minus 2, this mystery number, is 0, or this other one, x minus 4, is 0. It's the only way you can multiply two numbers together and get zeros if one of them is 0. So either x minus 2 is 0 or x minus 4 is 0, which means x is either 2 or 4. So that's our solution set. Okay, and let's do one more where it's easy to factor. So we're looking at solve 9x squared minus 4 equals 0. And this is a binomial, and it just so happens it fits a specific pattern that we're familiar with. If you recall in class, we learned about binomials can only factor if they fit a difference of squares, a sum of cubes, or a difference of cubes. This one's a difference of squares, right? Because this first term we could think of as the quantity 3x squared, and 4 is 2 squared, and they're being subtracted. So it's a difference of squares, and a difference of squares always factors into conjugates. So this one is going to factor into 3x minus 2 times 3x plus 2. Again, we have this 0 on the other side. If we didn't have that 0, we would have to move things around to get a 0, because factoring is only useful when you have standard form, 0 on one side. So that means that we either have 3x minus 2 equals 0 or 3x plus 2 equal to 0. That's the only way their product could be 0. And now we have to solve for x. So we're going to add 2 over to the other side. In this equation, we get 3x equals positive 2. So x is positive 2/3. Subtracting 2 on this side, we have 3x equals negative 2, so x is negative 2/3. So our solution set contains 2/3 and negative 2/3. All right, so these are all three kind of typical examples where you would use factoring. The first one, we had two terms that have x's in them. We could factor out a GCF. The second one, we had a trinomial with a leading coefficient of 1, so it's very quick to factor. And then the third one, we have a binomial that fits the difference of squares pattern.